Alright, so we're looking at 113, which is solving two variable inequality systems. So how do you know which region on a graph is the solution of a system of linear inequalities? Wait, what happened? Oh, okay. I thought I was frozen. And then solve systems of linear inequalities by graphing. Alright, so just like we do with linear equations, with inequalities, we have to solve to get into slope-intercept form, okay? So you have to solve y equals mx plus b. The only difference is we're going to have an inequality sign, okay? Now, before we do any of this, I first want to mention, and I'll put it on the last slide actually, and this will make sense as we go through the lesson. But if you have less than or equal to, greater than or equal to, you use a solid line. Exactly, yep. And then if you have less than or greater than, you use a dashed or dotted line. And the last thing I'm going to mention, now this isn't as important because I'll show you like another way to check. But if you have y is greater than, or y is greater than or equal to, you shade above. And if you have y is less than, or y is less than or equal to, you shade below. But to be 100% honest with you, this is one of those things that you're not going to always remember that. So I'm going to show you an alternate way that you can always check your work without actually memorizing this. Okay? You do have to memorize the solid and dashed line thing though. But I always just say you use more ink to use the equal sign here, so you use more ink to fill in the line. Alright. So back to what we were talking about. First thing you need to do here is you need to get the y by itself. So we have 2x minus y is greater than or equal to negative 3. I subtract 2x on both sides. That gives me negative y is greater than or equal to negative 2x minus 3. Now, negative y is the same thing as negative 1 times y. So I'm going to divide both sides by the negative 1. And when I divide by a negative over an inequality, I need to do what? Flip it. So that's going to give me y is less than or equal to 2x plus 3. So that would be my inequality in slope-intercept form. So now that I have my inequality in slope-intercept form, I'm now going to graph it. So you graph it the same way as you graph it if it were an equality. So my slope is 2 and my y-intercept is 3. So 1, 2, 3. And I'm going up 1, 2 and over 1. And it's going to look like this. And is this line solid or dashed? Solid. Good. And this is about the time when you're going to use your colored pencils. So you want to connect your line all the way to the edges of your graph paper. And I'll show you why that's important in a little bit. So this time you want to make sure your line touches both ends. Okay? Now we're going to look at the next one. I'm going to do this one in blue. But obviously you guys all have different colored pencils, so you just use whatever one you want. And this one's already in slope-intercept form, so I don't have to do any rearranging. So my y-intercept is 1, and my slope is negative 1 over 2, which means I'm going to be going down 1 unit and to the right 2. And it's going to look something like this. And solid or dashed? Solid. So it's going to look something like this. And now that we have that information, I'm going to then decide where to shade my above or below my line. So like I said, the rules follow as I said. Y is less than, you shade below. But say you don't remember that, which you most likely won't because there's a lot of different things you need to memorize in math. Here's a way to check. You can plug in the point 0, 0. In this case, 0, 0 would be below my line. If 0, 0 satisfies my inequality, that means that part of the graph is included and I would shade below. If 0 to 0 does not satisfy, you're going to shade above. Okay, so let's try it. So let's plug in 0, 0 here. So 0 is less than or equal to 2 times 0 plus 3. 0 is less than or equal to 3. Is that a true statement? Mm-hmm. Yes, so we're going to shade where 0 exists on that region. So you're going to shade here. Okay. Now we're going to do the same thing for the blue. Okay, the second inequality. If I plug in 0, that's going to be 0 is greater than or equal to negative 1/2 times 0 plus 1. 0 is greater than or equal to 1. True or false?
Wait, false.
False. So that means 0, 0 is not included, so I'm going to have to shade above, which we expected because y was greater than or equal to. So that's two ways to determine where you shade. You can plug in 0 or you can use the rules that I showed you. Either one will work. So does anybody have any questions on this one? If you're up in the front and you have a question, just say my name because I can't see you guys. Sorry. Alright. Moving on to example 2. First thing we need to do with this inequality is we need to get it into slope-intercept form. So I'm going to do that by adding 2x on both sides. That's going to give me 3y is less than or equal to 2x minus 6. I'm going to divide both sides by 3. And that's going to give me y is less than or equal to 2/3 x minus 2. Now that I have the line in slope-intercept form, I can graph it. So my y-intercept is -2, and my slope is up 2 and over 3. So 1, 2 over 1, 2, 3. Up 2 over 1, 2, 3. And then I can connect it, and this one is going to be a, what kind of line? Solid. Thank you. I didn't do a good job of that one. Good enough, you get the idea. So now we're going to do the same thing for this one here. I meant to do it in red. So my y-intercept is 1, and my slope is 2 over 3. So up 1, 2 over 1, 2, 3. Up 1, 2 and over 1, 2, 3. So this line is going to be dashed, right? Everybody understand why the line is dashed this time? Okay. So now we're going to determine where we're going to shade each one. I'm going to do the blue first. So in the case of the blue, I'm going to check and see if 0, 0 satisfies my inequality. If it does, I'm going to shade where 0, 0 is. If it doesn't, I'm going to shade where it does not. So 0 is less than or equal to 2/3 times 0 minus 2. That means 0 is less than or equal to -2. True or false?
False.
False. So 0 is not included, so we're going to shade below. And now for my second inequality, y is greater than. So since it's y is greater than, I know I'm going to shade above. But you can also use the 0 thing to check, like I showed you. Now, I think I forgot to explain like what the shading meant in the last question, so let me explain it here and then I'll talk about the last one a little bit too. Um, so what this shading basically means, so the region that the blue is shaded satisfies the blue inequality, this one. The region that the red is shaded satisfies all of the red inequality. And any of the region that is not filled in is what satisfies neither inequality. So any point in this region will satisfy neither. Now, the dashed line represents that any number that falls directly on this line will not satisfy the inequality, but anything above it will. And when it's a solid line, all those points on that line are included in satisfying the inequality. Now, there is no overlapping on this one, but if we look back to the last one, as you can see, there is this region where the two shaded regions overlap. And all that means is that region where both shaded regions overlap satisfies both sets of inequalities. Okay? That's what that means. Okay. So let's try another one.
Get a different color pencil. These two are similar.
Yeah, sure. What colors do you have? Oh, sorry. Yeah, those are like terrible colors. You can just keep it. I'll just collect them all later. Alright. Moving on. So let's try another inequality. So once again, we need to get our first inequality into slope-intercept form. So I have 4x minus 2y is less than or equal to 6. I'm going to subtract 4x on both sides, and that's going to give me negative 2 is less than or equal to negative 4x plus 6. I'm going to divide both sides by negative 2. And when I divide by a negative over an inequality, I need to do what with my inequality? Flip. That's going to become 2x minus 3. So y is greater than or equal to 2x minus 3. So now that we have both inequalities, I'm ready to plot them. So looking at the one circled in red, my y-intercept is negative 3, and I'm going up 1, 2, and over 1. And it's going to look like this. And my line is going to be solid. It's going to look like this, sort of. So that's what the red one is going to look like. And now we'll try the blue. So for the blue one, my y-intercept is 3, and I'm going to be going up 2 units and over 1. And what do you notice about these two lines? Good, they're parallel. Okay, they have the same slope. Parallel lines have the same slope. So these lines never actually intersect. Alright, and now we're going to determine the region of shading. You can use either the 0, 0 method, or you can use the memorization method. For the red one, I'm going to be shading above because of the greater than. And if you plug in 0 here, you'd see that 0 is greater than negative 3, so we're shading above. So that means we're shading all of this over here. So everything above the red is like this whole section. It's going to go right over the blue here. Okay. Now moving on to the blue one, remember we had to, that's not a, never mind, just kidding. That's this one. So in the blue case, it's going to be below, okay, below. So it's going to be down here. So what this situation means is this is basically saying that this region between the two lines satisfies both inequalities. The region over here satisfies just the red inequality, and the region over here satisfies just the blue inequality. So in this particular case, every region is shaded. There is no open region. So if you pick any point on a Cartesian coordinate graph and plug it into one of those, one of them is going to work. So that's what that means. So let's look at our last numerical example, and then we're going to do a word problem. So in this case, we're going to be looking at 3 inequalities, so that's where your third colored pencil is going to come in. So this and the last one. So the first thing I'm going to do is I'm going to solve this to get it into slope-intercept form. Good. So I'm going to add x to both sides, and that's going to give me y is less than or equal to x plus 1. And then with the red, I'm going to do the same thing. I'm just solving to get it into slope-intercept form. So I get this. And the last one is a little bit different. I can't get it into slope-intercept form because it doesn't even have a y, right? Now, last lesson with me, which would have been Monday for you guys, you learned about axis of symmetry, right?
Oh, that's just a straight, like, vertical line.
Exactly. It's a straight vertical line that goes through x is 5. So it's the same situation as axis of symmetry. Whenever you have x equals a number, it's always a straight vertical line through that x value. Whenever you have y equals a number, it's always a horizontal line. So let's go ahead and graph this. Let's look at the blue one first. So my axis symmetry, now I'm saying the wrong words. My y-intercept is 1, and my slope is 1, which means I'm going up 1 and over 1. And then for this situation, my line is going to be solid, and it's going to look like this. And next we're going to look at the red one. So for the red one, I have it down here. My y-intercept is also 1, and I'm going to be going down 2 units and over 3. So 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. So it's going to look something like this. And lastly, we're going to look at our green. Thank you. Yes. Good catch. I forgot about that. Okay. And then lastly, we're looking at x is less than 5. So that's 1, 2, 3, 4, 5. It's right here. And it's going to be a dashed line through x is equal to 5. So it's going to look like this. So now we'll go ahead and we'll shade. So for the red, y is greater than, which means we're going to be above the line. My thing's like lagging, so it's like, there we go. It's like over here. Now we're looking at blue, and blue is less than, which means it's going to be below the line. That scared me. And lastly, we're going to look at the green. So for the green, there is no above or below. So if you plug in 0 here, is 0 less than 5? Yep, so we're going to shade this side because that side contains the 0. So it looks something like this. So what this whole bit means is the region where all three overlap, which is right here, all three inequalities are satisfied by any point in this region. 2 of them here, 2 different ones here, only the green over here, and then only the blue down here, and then the blue and the red right there. So now we're going to do a real life example of this, how this actually comes into play and why we actually use these. So it says here, a school band is sponsoring a concert with the goal of raising at least $30,000. The tickets for balcony seats are $20, and they're $30 for the orchestra seats. And the venue has 1,700 balcony seats and 500 orchestra seats. So first thing we're looking at is I see the word at least. So when they say that, are they okay with making more than $30,000? Yes, they're just not okay with making less than $30,000. Now, tickets are $20 for balcony seats. Let's call balcony seats by the variable x. And let's call orchestra seats by the variable y. So first, let's set up our monetary inequality, so the inequality that involves money. So I know that I need to raise at least $30,000, and there's some tickets that are $20 and some tickets that are $30. So balcony seats are $20, so $20 times x, the number of balcony seats you sell, plus $30 for the orchestra seats times the number of orchestra seats you sell. That amount has to be greater than or equal to 30,000. So that's our first inequality. Now the other inequalities are dealing with these two situations here. Okay. So you think about a venue, you're not going to have unlimited seats, right? Now this inequality you could make way above the amount of money, but the problem is you can't sell more seats than you have, right? So for balcony seats, the number of balcony seats that we sell has to be less than or equal to 1,700. Does that make sense? Because I can't sell more seats than I have. And then the number of orchestra seats has to be less than or equal to 500 that I sell, because I can't sell more seats than I have. Okay? So now that we have that situation, our next thing we're going to do is we're going to actually graph this system of inequalities. But the first thing we're going to need to do for this one is we're going to need to get it into slope-intercept form. So I'm going to do that math down here. So I have 2x plus 30y is greater than or equal to 30,000. I'm going to subtract 20y on both sides. I'm sorry, 20x on both sides. That's going to give me 30y is greater than or equal to negative 20x plus 30,000. I'm going to divide both sides by the 30. And that's going to leave me with y is greater than or equal to negative 2/3 x plus 1,000. So this is going to be y is greater than or equal to negative 2/3 x plus 1,000. So now that I have that, I can go ahead and graph it. Now something I want you to notice about your graph here is this graph is going by 100s. The scale's by 100s. Now down here, this is x, and we know x is balcony. So the x-axis represents the balcony, and the y-axis represents the orchestra. So that might help you kind of visualize things. So for this particular line, now when we're looking at a graph, we're usually looking at 4 quadrants, but this one's just zoomed in on the first quadrant because we're not dealing with any negative values here. So my y-intercept is 1,000, and then I'm going down 2 units and over 3. But the problem here is I'm going down 2 units, but this is by 100s. So I want you to think about this for a second. Negative 2/3 is the same thing as negative 200 over 300, right? So I can go down 200 units and over 3 units, and that won't change anything. 1, 2 over 1, 2, 3. So down 1, 2 over 1, 2, 3. And this line is going to be solid or dashed? Solid. It's going to look like this. So now that we've graphed that line, let's go ahead and do the x. So we know that x is going to be a vertical line at 1,700. So that's right here, so 1,600, 1,700. And that's going to be a vertical line through that. Look like this. And lastly, we have a horizontal line at 500. Now we have to determine our shaded regions. So for the first inequality, y is greater than, so we're going to shade above. For the red, we know that x is less than 1,700. So all the values for x that are less than 1,700 are on the left. You can also do the 0, 0 trick if you prefer to. And then lastly, we have y values that are less than 500. Well, those are all going to be down here. So now we have our shaded in graph, and we can use this to help interpret the problems. Okay? So it says, will the $30,000 goal be met by selling 900 balcony seats and 300 orchestra seats? So we have to go up on both sides. So if we sell 900 balcony seats, that's right here, and 300 orchestra seats is like right here. So we go over and see, would that fall in the region that would you make the over $30,000 if you fall right here? No, because it's not in the region that the green is also shaded, so the answer is no. So you wouldn't hit max capacity in your seats, but you also wouldn't make enough money, so that doesn't work. Now for the next one it says, will the $30,000 goal be met by selling 1,100 balcony seats and 400 orchestra seats? That's going to fall right here. What do you guys think right here? Yes. And then for D it says, what does the point 1700, 500 represent? Anybody have an idea on that? 1700, 500. Anybody know what that represents? You got it. Maximum capacity, right? Good job. So what that means is that's your best case scenario, right? You max out all of your seats, and that's going to make you the most money while you haven't went over the amount. So that's like basically the best case scenario, is if D happens. And then E says, what is the region where the systems overlap indicate? So when all three systems overlap, what does that mean? It means that we reach our money goal, but we also don't exceed our capacity. Okay, so that's what that means. So it means that we reach the monetary goal without exceeding capacity. So that's what our goal is. So we have to fall in the region where all three are overlapping. Okay? So yes. Yeah, sure. Anybody have any questions related to the assignment? Alright, you guys have the rest of the period.